Welcome to EDU World Space.
So in this question, we are asked to calculate the escape speed for a 300-kilometer diameter asteroid with a density of 2,500 kilograms per meter cubed. So let's just quickly jot down some givens. So if the asteroid has a diameter of 300 kilograms, that means its radius is 150 kilometers, and so we can convert this into meters just by multiplying by 1,000. That'll give us 150,000 meters, or you can also write that as 1.5 times 10 to the 5 meters. And then we also have a density for our asteroid of 2,500 kilograms per meter cubed. And we'd like to find the escape speed. So in the book, there is an example which goes through the derivation of the formula for escape speed. This is example 12.5, and the formula looks something like this. And this is basically just derived using the idea that if the object is going to just nearly escape the main object, then at infinity, it's going to have a potential energy of 0, and all of its kinetic energy will have been used up, so the kinetic energy will also be 0. So this is basically just derived assuming a total energy for the object of 0, and then solving for the speed. Now, the only problem with this formula is that we do not currently have the mass of the asteroid. So we're going to have to use the information that we have in combination together to get the mass. So what I'm going to do is I'm going to use density is equal to mass over volume. This way I can find the mass just by rearranging this formula, density times volume. So I have the density, the volume is going to be, we're going to assume it's a spherical shape because that's really all that we can do here. So the volume is going to be 4 pi over 3 r cubed, and then we can just go ahead and plug everything in using that converted formula, or that converted value for radius that we found earlier. And when you plug this into a calculator, you should get a value of about 3.53 times 10 to the 19 kilograms. So now that we have our mass, we can just go back up here to the formula for escape speed and find what our escape speed is. So I'm going to go ahead and plug everything in. We've got our normal value for G, our M, which we just found, 10 to the 19, and our R is 1.5 times 10 to the 5. And once you plug that into a calculator and take the square root, you're going to get a value for the escape speed of 177 meters per second. So this is our final answer for this question.